Hello, G9 students. Welcome to my next video lesson. We finished a short chapter magnetism. Okay, thank you for writing a test. Grades are quite good. So let's start the last chapter in physics in the middle school, waves. Okay, and we will connect this chapter also with electromagnetic waves and other types of waves. Okay, so let's write point number of topic of today's lesson, because waves is a chapter, and topic is traveling waves. Traveling waves. Okay, I hope you are prepared to the lesson, pen, pencil, notebook, ruler, maybe some colors, because we'll be drawing a little. Okay. So first of all, what do you think what the wave is? Let's stop video for a moment and think what the wave is. After, let's say, 2 minutes, let's turn it back. Okay, so what is a wave? So we know that all waves transfer energy from one place to another. So you can write short characteristics of all waves. Okay, so they all transfer energy from one place to another. Okay, but this is not a simple transfer of energy, because let's imagine fossil fuel like coal. You can take a coal, place it on the truck, and move it from one place to another. We have also transfer of energy, but this is not, of course, the wave. So another and very, very important is that they do this without without a net motion of the medium. This is very, very important, net motion of the medium, through which they travel, of course. Yes? Okay, so again, waves transfer energy from one place to another without a net motion of the medium through which they travel. Okay? And of course, this is a third very, very important property. They all involve what? Oscillations or vibrations. Okay, so oscillations or vibrations are related with waves. Okay, so again, waves transfer energy from one place to another without net motion of the medium, and they all involve oscillations or vibrations. Okay, you can imagine two types, maybe not types of waves, but right, continuous wave, and wave pulse. Okay, so what is the difference between wave pulse and continuous wave? So continuous wave involves a succession of oscillations. Okay, so continuous wave involve succession of oscillation, maybe of individual oscillations. Okay, so we can imagine something like this. The sea wave, which travels from left to right, and water surface which is waving up and down all the time. This something is a continuous wave. Okay, and wave pulse is something else. Well, a wave pulse is only one oscillation. Okay, so wave pulse involves just one oscillation. Okay, so we can imagine, I don't know, a string which is extended and which is shaped just once, and this vibration, this pulse which disturbs the string, travels from left to right, and you can see at any time only one pulse. Okay, So maybe point number 3, examples. Okay, examples of waves. Of course, water ripples. Yeah, is a good example. And what next? It can be a sound. Sound is also a wave. Okay, light is completely different wave, but still a wave. Okay, oh, earthquake waves, also waves. Yes. Oh, waves along stretched rope. Waves along stretched rope. Okay, all are waves. Okay. So please copy this page, these 3 points, and next slide will be very important, because we can divide waves into 2 main types: transverse waves and longitudinal waves. And in the case of transverse waves and longitudinal waves, I'm going to talk also about 2 very important property terms related with waves: wavefront and array. Okay, so point number 4, array and wavefront. Okay, so what is array? Array indicates direction of energy transfer. Okay, so array shows or indicates direction of energy transfer. Energy transfer. Okay, so if a wave transfers energy from left to right, then the ray is directed from left to right. It's nothing else like a direction of energy transfer. Okay, and what is a wavefront? Okay, wavefront is a line which connects all points moving together. Okay, wavefront. In the case of typical waves, is a line which connects all points moving together. All points moving together. Okay, what does it mean? Let's imagine a sea wave. Yeah, I'm going to draw it in 3D. Oh, here we have a top of the wave, the middle part of the wave, the bottom of the wave, and let's imagine that this sea wave travels in this direction. Okay, so arrow I've created is a ray because it shows direction of energy transfer, direction in which energy is transferred. Okay, and wavefront. So let's connect all tops of the waves, all tops. This. So this line represents a wavefront. Wavefront, all points which are moving together, all points which behave in the same way. Of course, we can identify another wavefront, all bottoms of the wave. So if you will connect all the lowest possible parts of the Earth, yes, then we have a wavefront, also wavefront. So wavefront, line which connects all points that are moving together. Is it clear? So please copy this, array and wavefront, write what the array is and write what the wavefront is. When you will be ready, please turn the video again, because we'll be talking about 2 very important types of waves: transverse wave and longitudinal wave. So point number 5, transverse and longitudinal waves. Longitudinal waves. Okay, first maybe transverse wave, because it's easy to imagine. Okay, I'm going to use red for transverse. Okay, what is a transverse wave? In the case of transverse wave, direction of oscillation or direction of vibration, okay, is perpendicular to the direction of energy transfer. So let's write this: direction of vibration or oscillation, I prefer oscillation, is perpendicular to the direction of the energy transfer. What does it mean? Okay, let's imagine a typical transfer. Let's imagine a typical C wave. Okay, and let's imagine a buoy which is floating here. And let's imagine that energy is transferred to the right. So where is a wave in next instant? I can plot wave a second later. A second later will be displaced to the right. Okay, but it doesn't mean that objects which are at the surface of this wave move to the right. Okay, it doesn't mean that objects move to the right. It means that all energy travels to the right. What is the direction of vibration of any water molecule? This red marker will be moving up. Each point of the wave will be moving or up, creating new wave, or down, creating new wave. You see this? So what is the relation between direction of oscillation and direction of energy transfer? Energy is transferred to the right. Okay? So here again, energy. And particles, the droplets of water, the water surface, vibrates up and down. So oscillations are up and down in vertical direction, and energy is transferred from left to right in horizontal direction. So you see, these two directions are perpendicular. Okay, energy is transferred in direction which is perpendicular to the direction of oscillation, and this is something which is known as a transverse wave. Okay, what is the transverse? The example of transverse wave. Let's imagine that you have a stone which is thrown into a pond. Okay, so example, stone which is thrown into a pond. Okay, let's use Ibert's view. Okay, stone hits the surface of water here, and taps of the waves or wavefronts are distributed along this point. You see? So these are wavefronts. And energy is transferred also in all directions. So these arrows represent rays. So wavefronts are the circles, arrows are rays. Okay? So this is example of a transverse wave, a stone which is thrown to the pond. Another example of transverse wave is electromagnetic wave or light. Electromagnetic wave. Light is an electromagnetic wave. It's also a transverse wave. Okay, so please copy this and stop video. Copy this one. You will be ready. Last point, longitudinal. Still, we will be talking about the same point. About the next slide, I'm going to present longitudinal waves. Okay, so when you will be ready, please turn it. Okay, and the bullet point, a blue longitudinal waves. Okay, what are longitudinal waves? If you have a wave where direction of energy transfer is the same as direction of oscillation, direction of energy transfer is the same as direction of oscillation, then we have a longitudinal wave. Direction of energy transfer is the same as direction of oscillation. Okay, so let's imagine something like this. Oh, a sound wave. You have a speaker which emits a wave. Okay, and in the case of sound, in air we have a region of high density when particles are very, very close one to another, and a region which is rare. And next, again, a region of high density and a region which is rare. You see this? And these regions travel from left to right. Let's imagine that this is a receiver in ear, yes? A receiver. And here we have loudspeaker, something which emits sounds. So what happens? Energy is transferred from the loudspeaker to the ear, and particles vibrate left and right in the same direction as direction of energy transfer. So in this case, particles do not move up and down. Particles also move left and right. So let's look. Energy is transferred, in this case, in this example, in horizontal direction, and oscillations are also in horizontal direction. So I wrote here that longitudinal wave direction of energy transfer is the same as direction of oscillation. Energy is transferred in my example in horizontal direction, and oscillations are in horizontal direction. And this is longitudinal wave. Again, in the case of transverse, we have perpendicular direction, energy, let's say from left to right, and vibrations up down. In longitudinal, we have the same direction, energy, let's say from left to right, and oscillations are also left, right, right, left. Okay, example is of course sound I've created here. Okay, so again, when you have a loudspeaker which emits sounds, then rays are here, and wavefronts are represented by arcs. Are here, wavefronts. Okay. Another example of longitudinal wave is slinky. You know, the spring. Okay, you can create a compression and release it, and this compression will be traveling along the spring. So the turns, some turns will be closer to other turns, so turns will be farther from the others, but oscillations of these turns will be left-right, and energy will be transferred from left to right, and it can be observed by observations of this dense region traveling from left to right. Oof. Okay, we finished a very, very important lesson, Introduction to Waves. Okay, next lesson will be about wave characteristics. You'll know what is the period, frequency, wavelength, amplitude, wave speed, intensity, displacement, etc., etc. Please make a copy of this to your notebooks. Yes, there is no homework. You must know this. Again, this is the introduction to waves. Please learn this and make a beautiful notes. Okay, if you have any suggestions, comments, write in the form of post in Google Classroom. Learn physics, stay at home. Thank you for watching and goodbye.